Okay, so I'm gonna just read it, okay? So this, I forgot to record it. So before going to the next topic, I have to teach you the last high order systems, and the last problem is this electrical circuit that they are in the series, and you have two loops here. You have resistor here, inductor here, and also resistor here, inductor, and the capacitance. And what we're gonna find uh, transfer function of the capacitor or input voltage. And if you remember from electric circuit that we passed, for this situation, you're gonna have two loops, and you're gonna apply one current here and one current here for this loop. And based on Kirchhoff voltage law, you know that for each loop, sum of the voltages is zero for each loop. Having that, you start from the first loop, you have Vn equals to R1 I1, because I1 is for up, plus inductor is L1 di1 over dt, remember from the high school or the electric circuit one, plus R2, because R2 is shared between these two loops, so you're going to have I1 coming down, I2 is coming up, I1 minus I2, okay? Now the second loop is going to be R3 I2, because it's going to be I2, L2 di2 over dt plus Vc, because we're going to find this right now. Plus now this time, because it's mechanical spring, action and reaction forces, you have this time looking from this loop. So R2 this time is I2 minus I1, despite this. That's right. Then we're assuming that the initial conditions for the currents for I1 and I2 is zero, because we have a derivative here, and we're going to apply the Laplace transform to go to the frequency domain. By saying that, Vn is going to be R1 I1 capital L1 S, because derivative, now you know it. Derivative gives you S, L1 S I1, right? Plus R2 I1 minus I2, and here R3 I2 plus L2 S I2, we see, and these are the rest. Okay, everybody? So what I'm gonna do, I'm gonna resort what I developed here. So starting from this, you're gonna have V in, because you can factor out I1s from here. So you're gonna have R1 plus R2 plus L1S I1 minus R2 I2. Everybody agree? Just double check this one, I'm developing with you. Okay. Now this time here I factor out I2, so you're gonna have R3 plus R2 plus L2S I2 minus R2 I1 plus Vc equals 0. For simplicity of what we are developing later, so let me assume that R1 plus R2 is R4 here, here, and R3 plus R2 is R5 here. So now you can write simply like this. You can have, let me double check that everything is right, because minus R2A2 Vn and R3L2S plus R2 minus R2 I1. Okay, so you can write like this as a R4 plus L1S I1 minus R2 I2 is V in, and here you got R5 plus L2S I2 minus R2 I1 plus VC 0. So because we want to find the voltage of the capacitor, for God's sake, so we have to find I1 based on I2 and replace it here. Because finally we're going to find this transfer function of capacitor voltage over the input voltage. So simply, you know that the I1 from here is 1 over R4 plus L1S and V in plus R2 I2. Everybody agree? Yes? So can I go to the next page? Yes. So let me write it here. So I1 is 1 over R4 plus L1S V in minus, that's like R2 I2 R2 I2, and we have here R5 plus L2S and we have here R5 plus L2S I2 minus R2 I1 plus VC equal to 0. Okay. So what we're gonna do, I'm gonna replace this I1 here. But knowing that, before going ahead, we see, if you remember from the RLC circuit I was teaching you earlier, is what is it? Is well, remember that we see is here. Remember that the I in the capacitor I2 is C dVc over dt. Remember, for the capacitor. In the RLC circuit, we have in your notes. Okay. So, doing that, you're gonna have R5 plus L2S I2 minus R2 over R4 plus L1S V in minus R2 I2. Okay. Plus VC is 0. Hold on a little, I want to make sure that everything is right. Yes. Oh, this is plus. Why a root minus, guys? See, always double checking. It seemed funny to me. Plus. Okay. Yeah, just go to the plus. This is a minus. Yeah, that's right. Okay. So now you have I2 here. you can factor out. You have R5 plus L2S minus R2 square in R4 plus L1S, okay, in I2 minus R2 over R4 plus L1S V in plus VC is 0. You see that it's coming up, okay? But based on whatever I said here, you know that you can replace it here as, because this is time. So when you go to frequency having Laplace, remember I2 gonna be CSVC. That's right, derivative gives you S. Now you know it. So what you're gonna do, you're gonna replace it here with this I2. You're gonna replace it here with what is it? CSVC. Everybody understand what we have done? I2 is CSVC. So having that, now if I do this, let me first do this. So you're gonna have R5 plus L2S multiplied by R4 plus L1S minus R2 squared divided by R4 plus L1S. This multiplied by CSVC. But here, because you have VC, I'm factoring out. But here you have two VCs. Where is that? You have two VCs. Here you have plus 1, okay, VC, and I'm moving this to other side. You're gonna have R2 in R4 plus L1S win. So let us do this side. So if I let me do it. So I'm multiplying together. So you're gonna have L1 L2 S square plus 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 R5 L1 plus R4 L2 in S plus R4 R5 minus R2 square, and this multiplied by CS plus 1 divided by R4 plus L1S VC equals to R2 R4 plus L1S Vn. Everybody agree? So what I have to do, I have to just multiply by CS. If I do that, CS, you're gonna have a C here, this is gonna be 3. You have a C here, this is gonna be 2, and you have an S here, CS, and here we go. Everybody agree? I just multiplied by CS. I'm sorry. Here you have to, yeah, I have to fix it. Thank you for reminding me. Yeah, because it must custom, but even that it's there, no problem. Here you have to multiply this by 1, right? So here you're gonna have R4 plus L1S. Okay. So if you are done, I will move to the next page. Before going to the next page, for God's sake, this with this goes to New York. Everybody agree? Good. So before going to the next page, let me double check I did everything right. Okay. Yeah. Okay. So what I have now is this. C L1 L2 S cube plus C R5 L1 plus R4 L2 S square plus. So now you have a S here. You have to add inside here, right? R5 R4 minus R square plus L1. So you want to have R5 R4 plus L1 minus R2 square in S. See? And you have 1 R4 plus R4 in VC equals to R2 V in. Here we go. Okay. Okay. Everybody. Why we have a R2 here? Oh, we have R2 because of this. Okay, I'm gonna double check. So V in is R2I1. Yeah, that's right. Okay, so we get finally transfer function of Vc over Vn, the third order system. Gonna be R2 C L1 L2 S cube plus C R5 L1 plus R4 L2 S square plus R5 R4 plus L1 minus R2 square S plus R4. and the third order system, for God's sake. Now I want to make a simulation for this because I have too many things to talk about before connecting this to the next topic. This first set of the parameters, you know that because I told you R4 is R1 plus R2 that we assumed here. Get here, guys. And the R5 is R2 plus R3 is RO is R2 plus R3. So now let us say R1 I select as 1, R2 as 2, and R3 as 3. By saying that, first set of equation, your R4 gonna be 3 ohm. They are ohm. You know that in the electric circuit the units is ohm. And R4 is 5. So R5 is 4. 5. See here? Okay. Then I select the C. Capacitance is, I don't know, 10 microfarad. And the L1 is, I don't know. Okay, let me see. 15. So, by being said, I want to go with MATLAB and simulate the system for the values given. Okay. R1, because I want to make a point at the end of this class. R1, can you give me the numbers I assigned? R4 was 3. R4 was 3. R5 was how much? 5? Yep. C was 10. Hold on, please. Can you hold on, guys? So 10 microfarad means 10 to the power minus 6. I want to make sure that's around. L1 is 15, I said. L1 is 15. But I have to select another number, L2. L2 is, I don't know, 100. So L2 is 100. L2 is 100. So I have coefficient 1 is CL1 L2, CL1 L2. Coefficient 2 is CR5, okay, CR5 in L1 plus R4 in L2. R4 in L2. R5 L1, R4 L2. And R5 L2, okay. C3, coefficient 3 is R5 R4, R5 and R4 minus L1 square, yes, plus L1. Oh, minus what is square? R2 square. R2 square minus plus L1 plus L1. Guys, can you please check this for me also, because I'm typing the correct parameters. Can you hear me, everyone?
Yes, we can hear you. Yeah.
Everything is right? I wrote here. CL1 L2, CR5 L1 R4 L2, R5 R4 minus R1 squared plus L1 and the R4. That's right. Everything is right. Let me double check. CL1 L2, CR5 L1 R4 L2 R5 R4 plus L1 minus R2 squared plus R4. Okay. Okay. So when I'm doing that, because I'm gonna first, before going ahead, I'm gonna find the poles of this system. Solve coefficient 1 in x cubed plus coefficient 2 in x squared plus coefficient 3 in x plus coefficient 4. Okay. First I want to find the poles of this system. Electric circuit, third order. Okay. Let's see. Oh, I have to define R2 here. So R2 is, how much was R2? R2 15 plus, yeah, it's 2. So that's why I'm changing, yeah, fine. Okay. And I wanna say double on the poles equals to. Okay, you see that the system is stable. Do you see that? Because third order system, we have 3 poles and all of them they are on the right hand side, even if this complex conjugate pole is very close to that, but it's stable kind of. Okay, so it's not. So saying that, I'm gonna plot it figure 1 and say, oh, and say num is num1 is 0, 0, 0, 0, and you see that here is R2. A third order system, it's R2, and then one is coefficient 1, coefficient 2, coefficient 3, coefficient 4, S2, S. Why this has, oh, coefficient 4, oh, I forgot here this guys, plus R4, hold on, because the coefficient is this, coefficient S plus R4, so I forgot R4 from here, and you didn't tell me. So even if that, again, your system is stable. Okay, system is stable. So now on comment, coefficient 3, no, what's wrong here, guys? Let me hold on. C1, L1, L2, C this, C3 is this. No, that's right. What goes in here? So I only enter extra one here, S3, S2, S1. No, it's right. So okay. So now step function, I want to see the step response of this. Num1 and num and then 1. Okay, and grid for me. There we go. First of all, how this third order electrical system is under damped, critically damped, or over damped system? Yeah. Because we are plotting the voltage of the capacitor here actually. We are plotting the voltage of the capacitor here. We see this is plot of that. This is under damped, critically damped, or over damped. Is it under damped? Is it, guys? Do you know what's under damped? Have you heard about this in my class? Under damped? Yeah. Do you see oscillation a lot? Okay, so it's critically damped or over damped system, which is fine because we don't want that our voltage of the capacitor oscillate and settles down. We want to increase like this and then goes to the final value. See what I'm saying? See what I'm saying? Because maybe oscillation gonna hurt your capacitor. Understand? Yes? Good. So now let me select okay. So now let me select another set of the values. 2. Everything is the same. Okay. Only I change R2 to 10. Oh, 10 ohm. Okay. Here, what I'm gonna do, now this time, for doing that I have to change everything, guys. R1 plus R2 plus everything must change. Because I want to make a comparison. R2 plus R3, and in the previous case R1 was how much? 1. R1 was 1, and R2 in the previous case was how much? Yeah, that's right. R2. What's that? Okay. Yeah, here, I see. Yeah, okay. So R4, let me double check everything. R1, R2, R5 is R2, R3, yeah. Okay. So, thanks for telling me this. Okay. R4, R2, okay. Everything's fine now. Now, if I do this, first let me put a pause command here. Okay. And then I'm gonna have step no. Okay, fine. Now I'm gonna run it. What? Oh, I forgot to define R3. R3, what was R3? Was 3. Okay, good. Now, if I do this, your system is stable, guys. Okay, and if I continue this, what you're gonna get is still going to the 0.9. Okay, but there is some mistake here because system must becomes unstable because I selected R4, R5. Oh, I see. I have to select another number. Hold on, guys. By selecting R4, R2 is then R4 gonna be R1 plus 10, gonna be 11, and the R5 gonna be R2 plus 10, gonna be 13. Now, what? No, I changed R2 to 10. R2 plus R1. R1 is 1 is 11. R1 plus R2. 1 plus 10 is 11. I changed R2. And the R5 is 10 plus R3, 13. See what I'm saying? Okay, so now I have to select a number that gives you negative here. Hold on, I have to fix this. Okay, it's not possible because this is always positive. This is always positive. That's fine. But if you can find a number that which is not possible here, for God's sake, which is negative, your system becomes unstable. So my point is that, fine, I don't care. My point is that if you don't know the values of these parameters, the numeric, how do you know that your system is stable or how you know the system is unstable? Okay, and that's why here we are going to the last topic of this class, with the name of the Roth stability criteria. Okay, understand? Okay, Roth stability criteria, the last topic of this class. So, but before going there, let me finish this because I'm going to share this with you. X label gonna be time in second. It's recording, right? For God's sake, yeah. In second, and Y label gonna be V in voltage, volt. I'm sorry. Okay. Now here we go. Close it recording. Oh yeah, just showing the pause of the system. Here we go. Okay. So guys, do you see this? Let me show you again. Do you see this? It shows like as VIN, but I meant this. There's a trick. You could put also underline here. It's going to show the correct one. So let me first remove this pause. See, now VIN. See what I'm saying? If you want to do that.
Nice.
Okay. And there's no need for S because this is step response is plotting by itself. See, it's V in voltage and time seconds. Okay, understand? So that's it. I'm going to share this with you. So I'm going to stop it here because next class I'm going to begin the Roth stability criteria for the dynamical systems. Okay? Any questions? Thank you. Have fun, guys.